Gå ned. Gå ned. Go on.
Welcome, Charlie Murphy, to Go On Then. I'd like to talk to you about a project that I know that you're involved in 2016, 2017 at the Hub Wellcome Foundation. Can you tell us a bit about Created Out of Mind, the background and how it came to be and your involvement?
Created Out of Mind was a really amazing kind of lottery moment for me in my career, partly because I work across lots of different media. And it's not very often that is a sort of strength that people want to kind of harness. But I was approached by a man called Sebastian Crutch, who is a neuropsychologist who has been working with people with rare forms of dementia for over 20 years. Seb was the lead director. It was very much his vision, all these ideas that he'd accumulated over 20 years that had kind of started in embryonic form, and then he would invite a number of different practitioners across lots of different fields. So for example, we had an amazing man called Dr. Paul Kamick, who's done a lot of work with object handling with people with quite advanced dementias. We had Julian West, who's an extraordinary practitioner in music, who's been working with the Wigmore Hall for over 20 years, involved with a project called Music for Life. Those projects where they've brought, extraordinarily talented musicians together in a little collaborative team to work in collaboration with residents in care homes and staff has been going for a long time. So music was a particularly large proportion of some of the studies and some of the activities. So there was a big event that the team were involved with, kind of across the whole Wellcome, about music and well-being and so on, and kind of various podcasts and so on. So I was brought in as somebody with a lot of experience across a range of sort of visual as well as performative practices, particularly in the kind of area of participatory practice. And I had no prior knowledge or experience of working with people with dementia. I didn't have a science background, but part of the experience of being part of this this kind of amazing team was that it gave me an amazing kind of insight into what the science behind these conditions. There's over 200 different kinds of dementias that have been identified. So for example, there are some rare forms of dementia in the back of the brain, around the visual cortex. So something called posterior cortical atrophy is a condition where if dementia is degenerating the brain cells in the back of the brain, what can happen is that your visual perception starts to change and starts to warp. And it's quite subtle, but for example, people may experience weird kind of after effects. So say they move their hands. So there's an amazing description by a lady who was changing the sheets on her bed, and the sheets were particular colours, but what she started to see was like this kind of tracing with her hands where they were interacting with this colour, that she'd get the kind of opposite colour. So really, really quite disturbing things with your sense of distance and spatial awareness. So people with this condition, sometimes they will not be confident at walking down the street because the curb suddenly looks like a cliff, or they cannot judge or confidently go out into a space and navigate across the room.
I'd like to talk to you about Brains in a Dish.
So Brains in a Dish, this has been probably the most extraordinary project I've ever been involved with, and it's ongoing. This is a really epic body of work that I have launched into through the residency program. So one of the different areas that we've tried to address through this residency. One of our big missions, if you like, has been to try and deepen the public understanding about what dementia means, how the public might understand better what happens with dementia, because it's like any kind of health issue that you can't see. It's a very difficult thing to connect with or understand. A young molecular neuroscientist called Selina Ray, who works for the Institute of Neurology, and she has been pioneering some research that tries to understand on a cellular level what's going wrong, what are the very, very earliest stages of the disease, and how can we identify them, and what can we learn about the disease from that very early stage. And the way that she does that is to develop brain cell cultures and to study brain cell cultures in the lab. And the reason she's able to do that is because of the advances in stem cell technology and gene editing, which have really only come to the fore in the last sort of 15 years. But she has been able to utilize some of these new breakthroughs to start to really pick apart like what's going wrong with the proteins in our brains that lead towards the development of a dementia. So you would have heard about how somebody, for example, with Alzheimer's, they at an advanced stage will have developed these plaques in the brain, and it's a little bit like these little knots where the neurons basically, if the brain cells, if the proteins accumulate, they stop the neurons from being able to fire their little electrical pulses.
Mm-hmm.
And if they are no longer able to fire and connect and function, then they die. So what Selina's trying to do is to understand and to really study how tau behaves. And the way she does that is she's able to take a little tiny skin sample. So you'll see the slides on the website, but maybe a film. So they take a sample out of your arm and chop it up and start growing skin cells. Skin cells are really easily propagated. They feed it with a kind of cow juice, so it's like a kind of protein extract and sugars and various other things, and they incubate them and they grow lots of skin cells. They then apply a process called electroporation. They punch it with a strong electrical pulse, and what that does is it pushes out the instructions, the genetic instructions that say I'm a skin cell. And what happens is the cells, because they've lost that instruction that says go towards being a skin cell, what they do is they revert into a stem cell state. And a stem cell is this extraordinary cell type which can become anything. In this instance, they want to direct it towards becoming neurons or brain cells.
Right.
It's many different kinds of cells that are brain cells, but they are using that technique to create the brain cells specifically from patients that have got quite rare forms of dementia. So there's a familial Alzheimer's dementia, which it's only a tiny percentage of people that have this, but it's a really horrible, very, very aggressive form of dementia that can impact really early, so as early as 30. But what they're able to do is, by working with patients' skin samples and then developing these neuronal cultures from their skin, has their genetic material, they can actually study without intervening in that person's body any more than that little sample. They could start to see how their cells develop over time. And they can really look at how those neurons connect with each other, how they grow. They can measure the changes in the protein levels over time. And that's a really powerful tool for modeling disease and progression.
The glass work we see here, how does that fit with what I would describe to challenge and shape perception.
Part of the aim, yeah. Well, there's two sort of elements to the way that I have, as an artist, responded to this experience. So,
Yep.
I have participated directly in Selina's research by donating my skin cells, and then observing how she and her lab team have transformed them over time into neurons. So I've been making a film that documents that process. One of the ways that I work and that I try to think and make sense of things is through making. And because I've been working with glass for such a long period of time, I was really excited to go into the lab and the lab is full of glass. Everything is mediated with glass. Well, apart from the little trays are actually plastic, bit of a shape. But they use these kind of Pasteur pipettes for everything, it's a very carefully controlled environment, and you're looking through glass all the time. And so I was really intrigued by that, and I was also very intrigued by the color dyes that they use to try and identify different parts of the cell. And I started to experiment just with trying to make for myself, because when you're looking through a microscope, it's quite an abstract experience. I need somebody to tell me and talk me through, what am I looking at? How do I learn to look at these images, and how do I differentiate and understand what's going on? And so I was sort of remaking some of those images for myself in a more kind of tangible, sensual way. And then I started to work with an amazing electronics engineer called Robin Bussell, to try and direct light in a very particular way, to, in a way, emulate the kind of extraordinary interactions of brain cells through their synaptic activity.
Thank you very much for that, Charlie. I mean, it's been fascinating, and really appreciate you coming to talk to us about your work. And I hope to see you again in the future to talk more about your work, and particularly to see perhaps some of the video that you're making about the project.
Thank you very much. Thanks for asking.
You're welcome.